Good morning, ladies and gentlemen. Welcome to Kaduna State Senior Secondary School's online connect, powered by Exponential Computers. Physics lesson for SS1 students. Week 3 or third week of the physics lesson or physics class. I am the presenter Ismail Baraya. So for the third week or week 3 of physics lesson or physics class for SS1 student, here are the contents for the lesson. So the contents for the lesson, it says we have concept of heat and temperature. We have effect of heat on change of state, expansion and vaporization. We also have expansivity. So let's talk about the concept of heat and temperature. So normally a concept of heat is a form of energy. So heat, it is not just for the heating or for the fire. No, heat is a form of energy, and that energy is created, and it is called a thermal energy. So you see, heat normally is a form of energy, and that energy is called a thermal energy. So heat is the energy that is transferred from a hot object to a cooler object as a result of their difference in temperature. So if you look at it, heat is used to transfer a hot object or object that is hot to a cooler object. So you see, it is a transferring between them, between the object that is hot and the object that is cool. So between them, due to the change in temperature. And when we say change temperature, we are about to talk what is temperature just now. Okay. And temperature, when we say temperature is the degree of hotness or coldness of an object. So you see, the temperature is about the degree of hotness, and when we say hotness, we are talking about hot. So also the coldness of an object. So you see, this temperature is used to measure the hotness or the coldness of an object. It's used to find out the hotness or the coldness of an object. And also this temperature is used to be measured by a device called a thermometer. So you see, the device used for measuring temperature is called a thermometer. So a thermometer is a device that is used to find out how object is that object hotness or is that object coldness. So you see, this is due to the device that is used to measure the degree of hotness or coldness of an object. So you see, heat is a form of energy that is transferred from a hot object to a cooler object as a result of their temperature. So you see, this temperature is identifying of the hotness and the coolness of an object. So if you look at this diagram here, you will see that there is a firewood here. There is a fire. So this firewood is the source of that energy, is the source of that thermal energy, the one that brings the heat, and that heat is in a form of energy called a thermal energy. So that is for the heat. And if you look at this one here, it's talking about the temperature, the coolness of an object. You see this one, try this black thing that is going offward is trying. This one, it is a scaling. It's about to show the hotness or the coldness of an object. Is used to measure the degree of the hotness or the coldness of an object or of a body or of a particle. That is the temperature that is used to find out the degree of the hotness and the coldness or the coldness of an object. And the device used to measure the hotness and the coldness of the object is called the thermometer. That is the thermometer. That is the use of thermometer. It's used to measure the hotness and the coldness of a body or of a object. This is for the concept of heat and temperature. Okay, let's talk about the second context for this class, the context of effect of heat on change of state of the body. So addition of heat can bring about a change of state of the body. For example, when heat is added to a body in the form of a solid like ice, it will melt and change to a liquid form. Also, when enough heat is added to a liquid, it may vaporize or it may boil. So if you look at this diagram here, this diagram it is unlike an example of a of an ice. Just this water, the one that used to become ice, and water, when we put water in a fridge, it will become ice. So that ice, it is in a form of solid form. It is in a form of solid. So when you bring that ice and you try to put a heat on it, or the thermal heat on it, so that ice, before it is in form of solid form, so if you start putting pressure on it, you start if you start putting temperature on it, you start putting heat on it, it will start melting, and that melting, it will change into a liquid form. It will go back to its original position. So you see, due to the effect of heat, because if you do not put that heat, it will not melt. So due to that heat that you put on it, it will start melting, and that melting will change it into a liquid form. And if you keep on increasing the temperature, you keep increasing, maybe let's say a fire or a heat, or if you keep on increasing that heat, it will change from the liquid form, it will go up to the gas form. So if you look at it, and when it go to the gas up, you will see that it is trying to escape, because due to that heat that you put, due to that heat, that pressure that you put on heat, that is why it changed from the liquid form to the gaseous or to the gas form. So due to, so you see, this is the effect of heat, how heat affect the change of state of a body. So you see, that is why it will change from this form to this form to this form. So this, due to the effect of heat on it, that is why it will change. That is the effect of heat on change of state of the body. So let's talk about effect of heat on expansion of the body. Addition of heat will usually causes the expansion of a body. During expansion, the dimensions of the body increase. So you see, when we say expansion, is talking about the increasing in size of the body. So that is the expansion, and also that expansion, it will expand due to the effect of heat on it. So you see, any body or any object that you put heat on it, so it will expand. And when we say expansion, we are talking about it is changing, it will increase, the size will increase. So if you look at this diagram here, is trying to show you, or to show you the expansion of the body, how it will expand due to the effect of heat. So like a train, like a railway. So you see, the way. So you see, they are trying to expand. If you look at the first one, it is trying to bend. You see, it is due to the expansion, and that the expansion, it is caused by the effect of that heat from the train, because it is from the thermal energy from the train, that is the cause of the expansion. Because if there is no, due to that heat, it will not expand. So it is due to the effect of heat, how heat affect the body, how it expands, or it increase in size of the body. It is due to that heat that it is coming from the train. That is why it will expand. You see that the second one also, they are trying to bend. So this is the effect of heat on expansion of the body. Normally metal, it is the one that used to contain heat, but if the heat is too much heavier, it will too much on it, the pressure is increasing, then it will start to expand. It will expand. That is why It is due to the effect of heat, due to the affecting of the heat that is affecting on it, then it will expand. So this is about the effect of heat on expansion of the body. Okay, then let's talk about the third one, about the vaporization. Okay, as a result of an increase in temperature, like the kinetic energy of the molecule increase. Due to the increase in kinetic energy, the force of attraction between the molecules reduce. So also due to this effect of heat, it is affecting it is affecting on vaporization. So sorry sorry as a result of that heat, it will that is increasing in the temperature, the kinetic energy of the molecule, they will also increase. So you see, this heat or this temperature, it is the one that causes this kinetic energy to move and when we say kinetic energy, we are talking about the energy in motion. You will see they will increase due to that effect of heat on it, or due to that increasing in temperature on it. It will also cause the kinetic energy to increase. Due to increase in kinetic energy, the force of attraction between the molecules reduce. So you see, due to that kinetic energy that is moving, that is increasing, it will the force of attraction between those molecules, they will reduce. So you see, just like this example, if you see like the molecules, they are trying to escape, they are trying to go off. So due to that increasing in kinetic energy, and that increasing in kinetic energy, it is as a result of an increase in temperature, it is an increase in heat. That is why it will change, and the force of attraction between the molecule, it will reduce. So you see also this due to the effect of heat on vaporization. So this one also is talking about the effect of heat on vaporization. If you look at this diagram here below, you will see that the molecules, they are trying to escape. It is due to the as it is due to the effect of heat on them. That is why they are trying to reduce. So this is for the effect of heat on vaporization. So the third content of today's lesson is the expansivity. Expansivity is the fractional change in length or area or volume for a unit change in temperature at a given constant pressure. So you see, this expansivity is the fractional change. It is a changing, and that changes is in the length, or it is changing in the area, or it is changing in volume or on volume for unit change. You see, it is in temperature, and you see, when we're talking about the temperature, we're talking about the heat. So you see, change in temperature at a given constant pressure. So you see, the pressure is constant, that is expansivity. The pressure is constant, but the length or the area or the volume, it can change for change in temperature. You see, it will change in temperature at a given constant pressure. So you see, the pressure it is constant, but the fractional change in the area or length or volume per unit change in temperature, but the constant the pressure is constant at a given constant pressure. So this is about expansivity, the fractional change in length or area or volume for unit change in temperature at a given constant pressure. So this is for the expansivity, and it has three types, and those types are the linear thermal expansion, area thermal expansion, then we have volume or cube thermal expansion. And remember, when we are talking about this expansion, we are talking about the increasing or the changing in size of the body. So you see, we have a linear, we have area, we have volume or cube, and the thermal expansions. So this is for the expansion. So let's talk about the number one types of expansivity. That is the linear expansivity. Linear expansivity additionally depend on the original length and the final length. So you see the linear expansivity, it only depend on the original and the final lenses. So you see the linear is talking about the lenses of the expansivity, and the formula for calculating linear expansivity is the I, okay, no, the L, I mean the L1, and this L1 is the final length minus the L2, that is the initial one or the original length, divided by L1 theta, and this is this theta representing the temperature in rises in Celsius. It is in degree Celsius, so it is representing the temperature rises in degree Celsius. So this formula is for finding linear expansivity. So the second one is the area expansivity. Area expansivity additionally depend on the original area and final area. So you see also this one is talking about the depending on the original and the final area, because it is the area, it is not depending on the length, is not depending on the final or the second or the original or the final length. No, it's talking about the original area and the final area. And the formula calculating area expansivity is A2 minus A1, that is the final area minus the initial or the original area, divided by A1 theta. So you see this is the area expansivity, and this A2 represents the final area, also the A1 represents the final area. You see that this is how and this theta is is in degrees Celsius. It is in degrees Celsius, also representing the temperature rises in degree Celsius. So it is in degree Celsius. So this is for the formula for the calculating area expansivity. So let's go to the third one. That is the third type of expansivity, that is the volume or cube expansivity. Volume or cube expansivity depend on the original volume and the final volume. So you see also this one is not talking about the depending on the area or the length. No, it's talking only about also the depending on the original and the final volume. And the formula for calculating volume or cubic expansivity is, that is B2 minus B1 divided by B1. So you see this is the formula for finding cubic expansivity or volume expansivity. Also this B2 represents the final volume, also the B1 represents the final volume, also the theta represents the temperature rises in Celsius. So you see both of them, they are rises in Celsius, they are rising in degree Celsius. So and also both of them, they are depending on each other, they are not depending on if it is the area, then it is dependent on area. If it is volume or cube, it is dependent on that volume. Or if it is the linear, then it is dependent on the length only. So both of them, they are dependent on each other, and the temperature is in degree Celsius to both of them. So this is the about the expansivity, and this is for the whole lesson for the week. This is for the physics class for the SS1 student. So this is the end of it. Thank you for listening. I wish you good luck.